Hello everybody, this is my first of a series of chemistry calculation videos. This is on the structure of the atom. In this I'm going to look at first of all the most basic of operations, be able to work out the number of protons, neutrons and electrons in an atom. And secondly then, how to be able to work out the average relative atomic mass of an element from its isotopes. So let's get started. So I'm going to start with this. This is sodium, atomic number 11, relative atomic mass 23. Now, these are really important. This 11, as I said, is the atomic number. And what this tells us is the number of protons and electrons. So this means sodium has 11 protons, 11 electrons. So really important that. Now, if we look at the top number, the 23, this is called the relative atomic mass, RAM for short, and this is made up of all the particles which have a mass of 1. So this is protons and neutrons, so the total of the protons and neutrons. Now from this then please we can work out the number of neutrons. If the relative atomic mass is 23 and is made up of protons and neutrons, and the atomic number tells you the number of protons, to get the number of neutrons, if we take the relative atomic mass and subtract from that the atomic number, that will give us the number of neutrons, which in this case is 12. Now, I want to go back to the electrons now. Electrons, as we know, are arranged in shells. As we know, the first shell holds 2 electrons, all other shells hold up to 8. So, sodium has 2 electrons in the outer shell, so 2 from 11 is 9, so it's going to be 2, 8, and then 1. This 1 is really important because it's the outer shell and it tells us what group the element is in. So this is in group 1. And if it's in group 1, we know it's an alkali metal. The number of shells tells us what period the element is in. So because there are 3 shells, this is in period 3. Okay, now we can use this with any element to be able to work out the protons, neutrons and electrons. Now, my second calculation, as I said, was to work out the average relative atomic mass. Now, chlorine consists of 2 isotopes, chlorine 35 and chlorine 37. Now, naturally occurring chlorine contains 75% of chlorine 35 and 25% of chlorine 25. So the average relative atomic mass is a combination of these two. And how we work this out, so average RAM equals percentage isotope 1 times its RAM. And we do the same then for isotope 2. Percentage isotope 2 times its RAM. And because we're dealing with a percentage, we want the average, we divide by 100. So in this case, if we deal with the first isotope, chlorine 35, the percentage is 75, and its relative atomic mass is 35. The second isotope has a percentage of 25 and its relative atomic mass is 37. Divide that by 100. Now, take my word for this, that 35 times 75 is 2,625 and 25 times 37 is 925. When we add these together, that becomes 3,550. And as we divide by 100, that comes out as 35.5. And hey presto, this is the value that you will notice from the periodic table. Now, this technique you can use for any element, no matter how many isotopes it has. If it has 1, 2, 3 or more. If it has 3 isotopes, its percentage isotope 1 times its relative atomic mass plus percentage isotope 2 times its relative atomic mass plus percentage isotope 3 times the relative atomic mass and divide by 100. Now, if you use a straightforward formula, it works out every time.